All right, so number one. So here, first thing we want to do is check for a GCF, right? So a couple things. First of all, we're trying to solve, okay? So we're trying to find the solutions to this equation here. It's a quintic. The leading coefficient is 1, right? And so, first of all, we want to make sure one side is set equal to 0 if we're trying to solve, right? So that means we're finding zeros, roots, solutions, x-intercepts, all those things, right? And we'll see that in the next lesson where we're actually going to kind of talk about it more graphically again, or from a graphical perspective. So the first thing I want to do is check for a GCF. So the term, or I guess the term that is common with all of these is x, right? So I'm going to factor out an x. And that's the greatest common factor, right? There's nothing else besides x that goes into those bigger, that's besides 1, right? That's bigger than 1. So now when I factor out an x, I'm going to get x to the 4th minus 6x squared minus 27, right? So remember, what we're doing is we're essentially dividing each of these terms by x, and then we're putting those back inside, right? All right, so now this is a trinomial, right? And so I have a few options, right? I can do, it could be a perfect square trinomial or general trinomial, right? And so here we know that a is equal to 1, so that looks like a simple quadratic. This is not a perfect square, so it's not a perfect square trinomial, and so it's just a simple quadratic. Okay, so what I'm going to do is I'm going to set it up like this, and I'm looking for, and I know this is going to be x squared and x squared. Okay, so now I'm looking for two numbers that have a product of 27 that have a sum of -6, right? So those numbers are 9 and 3, right? So I'm going to put those in here, 9 and 3. Now I have to get the signs right. So here the sign, this tells me the signs are different, okay? And I want to end up with a -6. So that means my bigger number is going to be negative, right? And the other one's going to be different. All right, so remember, zero product property, or zero factor property, says I can set each of these equal to 0, right, and solve. But I actually have a little more factoring I can do, right? So now inside here, this is already done. I can't do anything with that. But here I have a difference of 2 squares, right? This one is not a difference, and it's not, 3 is not a perfect square anyway, so can't do anything with x squared plus 3, but I can do something with the x squared minus 9. So I can turn that into 2. Let me bring down the x squared plus 3. Okay, so I can turn this into x plus 3, x minus 3, right? That's how we do difference of squares. All right, so now that's as far as I can factor. So I just factor completely. So now I'm going to look for my answers. Okay, so you can go straight to the answer too if you'd like. Like here, x equals 0, right? That's pretty obvious if I set that equal to 0. So that's one solution. Okay, remember, if this were a number like 5, then it wouldn't matter. But since it's an x can equal 0, and if I make this a 0, that will turn this whole thing into 0, right, and make the equation true. All right, so my next possibility is going to be x equals -3, right? So that's one solution. Or x equals +3. All right, so those are 3 real solutions that we just got, right? And remember, if you need to, you can set these up into equations and solve that way, right? So I kind of did the shortcut just by changing the signs, but you can definitely set them up as equations if that helps. Now this next one, this one's a little tricky, so I'm gonna set it up as an equation. So what I'm going to do is I'm going to subtract 3 from both sides. And so we get x squared equals -3. And now I want to use the square root property to take the square root of both sides. Don't forget the plus or minus. And so here square cancels out a square root. So we end up with let me write this down here, x equals plus or minus. Now what's going to happen, since I have a negative underneath the square root, I'm going to pop an I out, right? So it's going to be plus or minus I, and then 3 is a prime number, so I can't, there aren't going to be any pairs. I can't really break it down into a factor tree, so it's just going to stay inside. So it's going to be plus or minus I root 3, right? Which, remember, that's 2 answers, so you don't have to write this out, but remember that means I root 3, and that means negative I root 3. Okay, so those are all of our answers. So we ended up with 1, 2, 3, 4, 5 answers. All right, now just to give you a little insight here, we have 5 roots and we have a quintic, right? So that's 5 roots are the most you can have with a quintic, right? So the power of the polynomial, the degree of the polynomial, tells you how many possible roots you can have. Okay, so notice how quadratics we can have up to 2 roots, right? And then quartics we can have up to 4, and so forth and so on. Okay. All right, so we have 5 answers on this one. So a lot of factoring. We did GCF factoring, we did simple quadratic factoring, we did difference of square factoring, and then we had to use the square root property as well to solve for our variable there. All right, so number 2. So this time there's no GCF, right? So no number that we can factor out of all of those terms that are bigger than 1. So I see that it's in the quadratic form, right? Even though this is not a quadratic, it's a 8th degree polynomial, but I can still factor it in quadratic form, right? So I'm going to put x to the 4th here. And by the way, I didn't mention this explicitly, but basically to find these, we're just dividing this in 2, right? So we take this exponent, divide it in 2, or you can actually just look at the middle one, and that also tells you what it is, right? But remember that this should be half of this, or you can think of it as this is double what this is, right? All right, so now I'm looking for 2 numbers that have a product of 36 and a sum of 13. So that would be 9 and 4, right? So I'm going to put 9 and 4 here. So this tells me the signs are the same. And so this is the sign of the bigger number. So it's going to be -9, -4. All right. So now from there, I can factor some more because these are actually both difference of 2 squares. So what I'm going to do is I'm going to turn this into something like that, this into this. And so what I'll end up with is x squared minus 3, or x squared plus 3, x squared minus 3, and then x squared plus 4, or plus 2, excuse me, and x squared minus 2. So all I did is take the square root of these, right, and that's how I get these values. The same thing with the 4. Square root of 4, I get 2 and 2. All right. Okay, and then just make sure the signs are different, just like we did over here. Now, one thing with this is we still have squares here, right? Now, if this were a perfect square, it would be a difference of 2 squares, right? Same thing over here. But 2 nor 3 are perfect squares. So so we're just going to go straight to the equations from here, okay? So I'm going to go x squared plus 3 equals 0. So I'm going to take away 3 from both sides. We just did that over here, right? So I'm okay with you going to the answers from here, but just be really careful with your signs. So take the square root of both sides. Don't forget the plus or minus. Here we're going to pop an I out. So it's going to be x equals plus or minus I root 3. Okay, let me put a barrier here. All right, for this next one, x squared minus 3 equals 0. It's going to be very similar, except for we're going to be taking the square root of positive 3. So we get x squared equals 3. So when we take the square root of both sides, we don't need to pop an I out, right? So it's just going to be x equals plus or minus root 3. Okay, no I, right? So far we have 4 answers, right? 2 here and 2 here. And we could end up with possibly up to 8, right? So we're like halfway there, it seems like. So now if you see the pattern, you can go straight to the answers for these next ones. So x squared plus 2, it's going to be very similar to x squared plus 3. I'm going to have to subtract 2 and then take the square root. So I'm going to have a radicand. So I'm going to have to pop out an I. So this is going to be x equals plus or minus I root 2. And you can't simplify root 2. Okay. And then this one's going to be very similar to this one. So we're going to get x equals plus or minus root 2. No I on that one because we're going to have to add 2. And so we'll end up with a positive radicand. So those are our 8 answers. Okay. Plus or minus I root 3, plus or minus I root 2, plus or minus root 3, plus or minus root 2.